Life is like a hurricane here in Duck. Oh, hello there. Hey guys, what's going on? Memes here. So, yes, as I was watching yet another Wolfram physics video, link in the doobly doo below. Right before I came on, apparently I got a treat. Apparently, Lex has another interview with Dr. Wolfram. I highly look forward to listening to that. Now, as far as what's actually going on, Professor Wolfram, take it away.
So what this is basically saying is, if we thought about this in space-time, if you say all pieces of space are equivalent, then anything that happens anywhere is connected.
We're all connected?
Mm-hmm. And that's why all these events get connected.
Go on.
By virtue of the identification of different parts of space, basically.
Right.
Maybe.
Whereas if the different parts of space, it isn't quite the level of atoms of space, but if the different sort of fragments of space were completely separate, then the things that happen to them are happening separately.
Mm-hmm.
Symmetric. Okay, so for A goes to AB,
we
could
go
you
to
show
here.
A
We're
goes to
tracing
AB
a very
in a
elementary path.
And don't deduplicate the tokens.
What do we get? It doesn't work. Maybe.
Okay, why is that null?
Maybe we need to balance it
for an
somehow.
even number. Okay, hang on. Let's have a look.
An even number, you say? What could we get?
Yeah, that's pretty dull.
I like that shape. It's a triangle.
Okay, so what is that? What is that?
Four of them going to a tetrahedra.
We were extracting the causal
Two
branch of graph, and there's only ever
tetrahedra.
going to be one event at each step.
Glued together via the appropriate Dane surgery.
It's dull.
Going to lead to the hyperbolic
to be
figure eight
thickened
knots
up.
complement.
Look, that's what it looks like.
Oh, looks like an action leads to
Well,
another
okay,
action
so
leads to,
we might
and
need
again,
a rule that has a bit.
Hey, I'm a proud ruleologist. Thank you, Professor. But all I'm saying is if we keep trends going down that way, it's very interesting. Because if we stop sharing that, and then we pop over here, and we share this. Oh, wait, what's this? I found an article. It was from back in like 2004, 2005. Principles of the Theory of Vortex Gravitation. How did I find this? I typed in vortex effect gravity or gravitation. It's been cited once. The developed theory proves that a universal vortex motion, along with a pressure variation in space continuum called ether, is actually the source of universal gravitation, the creation of celestial bodies, and their motion in the universe. Calculations of the gravitation forces are carried out on the basis of the laws of mechanics of continua or aerodynamics, with the use of the Navier-Stokes equations. That's the stuff for fluid dynamics. As a result of the solution, an algebraic formula for the gravitation forces is obtained. The reliability of this formula is supported by its conformity to astronomical data and also to Newton's empirical formula for universal gravitation. The main advantage of the proposed theory is that on the basis of it, it is possible to explain all the phenomena and laws observed in the cosmic space, viz., the motion of celestial bodies, mutual closing and moving away of galaxies, and origin of celestial bodies, black holes, and the universe as a whole, the nature of gravity, the speed of gravitation, the strengths of magnetic fields of celestial bodies, etc. That's a very bold claim. From what I saw through the article, they don't explain all that. There's a couple of short sections or anything. But at least it sounds like the ether, one may view that as, I don't know, a superfluid. That has a video on that. I didn't like that when I linked to the thing that we're getting to. As we can see here, the principles of the theory. The proposed principle of universal attraction forces is worked out on the following basis. Cosmic space is filled with a cosmic matter, ether, which forms an infinite spatial system of torsion vortices. The physical characteristics of the ether are a density, Looks it says 8 comma, but I believe that's a typo. Also, probably why it only has one side. Then again, it wasn't the prevailing theory at the time. I see you there. I see you there. Thank you for joining, Wookie. All I know is we go back here and we can see, okay, 8.85, assuming, to 10 to the negative 12 kilograms per meter cubed. At a pressure of 2 times 10 to the 32nd. I believe that's Pascal. Oh, interesting. The temperature is 7 times 10 to the negative 51 Kelvin. I looked that up, and 0 degrees, absolute zero. It's actually negative 273 degree 0.15 Kelvin. This is like negative 273 point. You actually need to extend the digits 0.149999. Like, I don't know, was it something like 40 or 50 times like that, and then it's like 6 or something like that, 763 or something like that. It's an incredibly small amount. I've been trying to figure out the calculations, but we had that, as well as more recently in 2016, gravitational vortex detected around black hole. Astronomy.com/news. Like a whirlpool created by stirring a cup of coffee with one of those tiny straws. A spinning black hole creates a gravitational vortex in the space-time around it. A European Space Agency, ESA, project recently detected the effects of the gravitational vortex, or frame dragging, around black hole H1743-322, thus confirming another prediction of general relativity. I'm a fan. And as I'm a fan, we need to stop doing that, and then we go back in here, because I haven't brought up to date my OBS yet. So we go over to Thad's guided reading of his new book, 44, Part 2. Thad, take it away.
This balance also
Clip it,
extends to set the possible tessellations of all the allowed 17 fundamental values of mass, mirroring the division structure of the hyperbolic figure 8 knots internal complement volume,
Oh,
which is composed of 6
Well,
circles with an inside circle, so 7 circles in its most general decomposition. That construction on the inside.
that's beautiful, Thad. I think I meant to show that part after. Doesn't matter. We're going back to Wolfram, because there's just so much interesting stuff that's going on. I'm looking for patterns. I'm a pattern recognition creature, as we can see. And again, I would be looking for 5, but it also goes to 6. This continued iterations, they may say. All right, as we go to 119 on the map here. Why did I show that? Well, the reason was 1907. Here we go.
This
It's
is going to
a
be
horrible mess.
A
It will be
horrible mess.
actually. I can make it a bit faster if we don't do the rendering.
Generating in more of a
But
two-dimensional.
yeah, it'll be something like that.
Oh, it's very
Okay.
interesting.
All right.
1, 2, 3, 4, 5, 6. Connected at a central point there. Again, I am totally looking for things, but I look at that. I look at that. I look at that. And I look at that. The reason why I say this is because right now I'm currently filling up time while I actually swap over to the thing that actually shares the volume with us in this tab. So as we can see here, we need to go back to 129 because I have notes because we can.
Space-like separations, right? They're telling you antichains, these orange edges.
Anti-chains,
One way you can think about them. And then these are telling you antichains in the branchial graph, the purple edges. And then there's mixtures between the two, which are also encoded.
Mixtures
All right,
of things.
Okay. Now I'm more excited. Okay. So you're saying that hanging around some of the spatial structure, they're little pieces of branchial froth, basically. But if we think of this thing having a backbone that's the spatial causal connections.
Right, this thing here.
Yes. But so what that's saying in the picture above is that there is no branchial connection between one side of space and the other. Is that right? At least there's no one-step branchial connection between one side of space and the other.
Right. There's an entanglement horizon here.
Well, but this is only recording.
It's beautiful. The thing is linked in the doobly-doo below. I mean, all I know is I just keep seeing all these things. And again, what you're trying to calculate out, and then it just completely blew my mind when I realized, wait a second, the blank mass isn't the smallest mass, it's just our smallest observable one that we happen to be able to calculate. This is very interesting. It's almost like it's wrapping around of the smallest possible mass boundary itself, which the hyperbolic figure 8 knots complement. When you decompose it, well, that's what that's proposing. And all I know is I came into this and I was so happy. And then it's even better. Why? Because Lex came into the picture. Mr. Friedman.
In our search for meaning, and some are just what the comedian Tim Dillon calls fun. This is the Lex Friedman podcast. To support it, please check out the sponsors in.
All right, thank you, Lex. Yes, just released. So the link as well is in the doobly-doo. Why? Because it also feeds the algorithm. Because it's not like anybody would be looking for that stuff at this time. Apparently, you're supposed to play a game. I've been pretty bad at it, I guess. I guess I continually am. Hey, you do what you gotta do. I see you there, Osnair. But other than that, peace out, everybody. Be safe. And just remember.
It's turtles all the way down.
Peace out, everyone.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.